Hi, Ryan Boyd here, and for this tutorial I'm going to walk you through some of the more advanced settings for how to use the mean extraction helper. So in the original video, the basic tutorial, we went pretty quickly. We just chose input and output settings and then went from there. We analyzed the data, we covered briefly the frequency lists and so forth. Today I want to show you what some of these different settings do. So I've already gone in and turned off several of the options for the mean extraction helper so that you can see what they do as we turn them on step by step. So what I'm going to do is I'm going to go back to the TED Talks dataset that we covered in the other tutorial. And instead of using these separate text files, I'm just going to use the CSV file. So this is a spreadsheet that contains all of the TED Talks along with some extra information like the number of views and so forth. But we have this column here, transcript, that has the full text of each TED Talk. And I'm just going to use this file because it's a little bit faster to analyze text when they're all contained in a single file rather than analyzing text split across several files. So that'll make working through the tutorial a bit more expedient on my side. So I'm going to go ahead and open the CSV file, and it's going to ask us what column we want to use as the row identifier. For this case, it doesn't really matter much. I'm going to go ahead and use the file name column, and then the column containing our texts will be the English transcripts. Now all that I'm going to do right now is just have it generate a frequency list. So you can see that I've gone through and I've cleared out the conversions list, the stop list is empty, some of these settings are turned off. So I'm going to output our frequency list here in the texts folder that I have. You can see that right now I'm only generating a frequency list and nothing else. So I'm going to go ahead and click start, and it should just give us the document word list and then a frequency list. There's our document word list that we saw before. And here's our frequency list. So if we go and open up our frequency list, I'm going to go ahead and sort by frequency from high to low. And you can see there's a bunch of words in here that we didn't get last time. This includes pretty much all of the tokens or words or units of text that we've extracted, including a lot of these really common function words like the, and, to, of, and so on. And you can see these are really common words. Things like commas and the word the have really high frequencies, and they also appear in virtually all of the text. The word the appears in pretty much every single text, 100% of our TED Talks. And the same is true for most of these. Now typically when you're doing topic modeling, and in particular the mean extraction method, we don't want to include a lot of these words. Now there's a couple reasons for that. The first is that we're trying to extract all the different themes from each of the texts. So the word the doesn't really have any meaning to it. It's called a function word. It's a part of speech that is used to string together content words, words that have some kind of meaning. And so we don't really want to include a lot of these tokens because they don't have any inherent meaning. Now there's a second reason that we want to omit a lot of these common function words. And the main reason is that because they are so common, what they're going to do downstream is screw up our analyses. When we want to perform something like a principal components analysis, what it's really doing is finding how all of the words correlate with each other and then giving us clusters of intercorrelations. So in the previous tutorial we saw words like mother, father, child, all clumped together onto a single factor. This is because they are all strongly intercorrelated with each other. When people use the word mother, for example, they're also more likely to use the word father. When we have words like the and that appear in every single TED Talk, we can't really discover intercorrelations because the word the, since it appears in every text, it correlates with every other word. So what we want to do is we want to omit a lot of these really common words, all of these tokens that don't carry some kind of analytic value for us. Now we do that using something called a stop list. A stop list is a list of words or tokens that we want to omit as we move forward with our analyses. Now, Mean Extraction Helper has a lot of stop lists built in by default for different languages. So this English stop list is one that was provided by Cindy Chung and has been modified a bit over time. If you're analyzing text in a different language, for example, Turkish, you can click that and click Load Stop List. And it's going to include a lot of these common characters that we want to omit, as well as a lot of common Turkish words that would normally be included in a stop list. Same is true for German. And we'll go back to English. Now you may want to add or remove something from these stop lists that are built in. So for example, the word despite is in here. Maybe you think that this is a word that you do want to include. So you can go to the stop list text box and remove words, or you can add words that you would like to omit from your frequency list and the downstream parts of the analysis. Now sometimes you'll want to do this given the specific context of your data set. For example, one time I was analyzing a data set full of dream reports from dream diaries, and this data set, everyone essentially opened up their writing with, in my dream I dreamt about blah 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 blah. And so because the word dream wasn't particularly meaningful in this context and also was extremely common, I added the word dream. Now with this stop list loaded, I'm going to go ahead and run the analysis again, and it's going to replace these two files that we had from before. Now once it's finished, we'll open the stop list back up, and what you'll see is that all of those stop words that were in that list are going to now be removed from the frequency list. And so when we sort this from high to low, you can see that now this is starting to look a lot more like what you saw in the first tutorial. Words like the and have been removed, a lot of that common punctuation has been removed, and so what we're left with here are words that have much more analytic value to us. These are more meaningful words that have some kind of content or semantic property to them that we can use for topic modeling and other types of analyses. Now what you'll also see is that the observation percents are a bit more reasonable. So there are still some of these words like people that are very common, but it slopes off very quickly. So very quickly we get down to words that only occur in about half of the texts. And this is actually something that follows what is commonly known as a Zipf distribution. So if we plot the frequency of all of these words, let's just say even the first, 1,600 words or so, what we're going to see, where is my plot button? Insert, plot. what we're going to see is that most words occur very few times. There are words like people up here that occur a lot, but very quickly we run into really uncommon words. And for most of these data-driven and text analysis methods, what we want to do is we want to omit words that appear very infrequently. So you can see as we scroll down, most of the words, we're about halfway through the list, most of the words are only occurring 2 times. The overwhelming majority of these words appeared just once. These are words, for the most part, we really don't care about. What we care about are all these words up here at the top of our list. Now, when we're doing a lot of topic modeling methods and other data-driven methods, we want to combine words that mean essentially the same thing. So here, if we zoom out a little bit, we can see that the word years and year both occur pretty frequently, but they're being handled as separate words right now. Now, for the most part, we don't really care about separating all the words into their different forms. So what we want to do is we want to combine words that mean essentially the same thing, but just have different inflections. So words like year and years, we want to combine all of these just to be year. For words like run, running, runs, and ran, we want to just combine all of these into the basic word form, which is run. Now we can do this using a process known as lemmatization, also sometimes spelled lemmatization. Lemmatization is a process by which words are given to an algorithm, and the algorithm tries to determine what is the simplest form of this word. We use lemmatization to essentially do this process for us, to convert words like years and year into the common basic form. Now this is slightly different from something known as stemming. Stemming is a different type of algorithm that does a similar thing, but not exactly the same thing. So what we want to use is lemmatization. And let's just check this real quick. So the word years occurs 9298 times in our data set. The word year about 3,600 times or so. And so when we combine the two of these, we should expect, I don't know, around 1,400 or so instances of the word year. So I'm going to go back to main extraction helper and turn on lemmatization, which is under the token handling options. So we want to use automated or algorithmic lemmatization, and we're going to do this for the English language. There are lemmatizers that are built in for many other languages, not all languages, but many languages. Now just know lemmatization is not always perfect, but we'll come back to that in just a minute. For the most part, it's good enough for most cases. And within all of these lemmatizers, some of them work better than others. The English lemmatizer is very good. The Italian one is okay, but not great. So we have the lemmatizer turned on, and I'm going to go ahead and run this again. It'll regenerate and replace this frequency list. And what we should see when we look at this new frequency list is that all these different forms of the same word have been converted to the basic form and combined with each other. So when we sort from high to low, we see that many of these have now been combined. So the word year, the frequency should be about the sum of what we had before for years and year separately. So the lematizer has worked there. Now, if we go in, we'll see there are some odd cases here. There's UB, IB, odd words that have been combined with each other. This is common for a lot of lemmatizers. They'll take words like I'm and convert them to I plus am, which then gets converted to I plus B, because B in English is the unconjugated version of the word am. So you have words like you are, he is, she is, I am. These get converted into you be, he be, she be, and I be, and then they get converted to each of these. Now, generally speaking, not a huge problem, but we do want to ignore those. Now, there's another issue here in that a lemmatizer, as I mentioned before, is never perfect. So there are some odd cases, like the words working. So the word working can be either a verb, as in I am working hard today, and she is working on the machine. Working can also be a noun. So I don't understand the inner working of this machine. Now for the verb form of the word working, the simplest version is the word work. So you have words like work, working, works, and worked. So a good lemmatizer will recognize that all of these are a version of the word work and convert them to the more basic form. For the word working as a noun, this is the simplest form of this word. So you can have words like working and workings that should be converted to just working. Now, most lemmatizers aren't going to understand the difference between these two forms of working, and so sometimes it will encounter the word working as it's analyzing your text and say, I don't know which version of the word this is, so I'm just going to leave it alone. There are other cases where a lemmatizer encounters a word that doesn't really know or understand how to convert, and so it just leaves it alone. So there are a lot of cases like this in every language where a lemmatizer does pretty good, but doesn't do everything as well as it should. And so, in the main extraction helper, we have this extra option, a conversions list. And a conversions list allows us to manually specify words that we want to convert into other words. Now, there are a lot of these built into main extraction helper by default for a couple of different languages. This includes converting URLs into a single word. This includes a lot of misspellings that are common. And it also includes some things like, BF to boyfriend. Words where there are different versions of it that a lemmatizer isn't going to recognize that are common that we want to convert to the same form. Now, like the stop list, we can add in other versions. So we can take the word dream, as I mentioned before, so dream and dreaming and dreams. We can convert those into the word dream manually if we need to. The conversions list can also use wildcards, so this is an asterisk here. Now what this will do is this will convert any word that starts with dream and convert it into the word dream. So this will capture a word like dreams and dreaming. So if we run this one last time, it's going to go through this whole process again. It's going to replace our lists here. and this time it will use the conversions as well. So it's going to change some of these things that the Lemmatizer might not recognize or mess up. It's going to correct any misspellings that are in there. But for the most part, things are going to look about the same as they did before. And you can notice that some of those odd cases, like IB and UB, are now gone because the converter has already handled some of these. But for the most part, the words are about the same, the numbers are about the same. Everything looks pretty good. And so that is essentially all that you need to know about some of the more detailed nuances of what the mean extraction helper is doing to take your input texts and convert them down into these common forms that you can then use for subsequent analyses.